Hello everyone and welcome back. In the previous session, we were introduced to the number representations, and in that session, we also studied about the binary number system. Today, we are going to learn about the hexadecimal number system. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, at first we will learn about the hexadecimal number system. Thereafter, we will have a comparative study of decimal, binary and hexadecimal number systems. Finally, we will end our session learning about the representation of binary in hexadecimal. So let's begin with hexadecimal number system. Now in the previous session, if you remember, while we were learning about the number systems, we came to know that in hexadecimal number system, we have got 16 symbols. And due to this reason, the base of the hexadecimal number system is 16. Now coming to hexadecimal, we have got 16 symbols. And what are the symbols? We have got the symbols 0 to 9. Then we have A, B, C, D, E and F. Let's now understand how in hexadecimal number system, the numbers are formed using these symbols. Similar to other number systems, the first 16 numbers of the hexadecimal will be formed using the 16 symbols of hexadecimal. Now, in order to form the number after F, we are going to select the symbol which is next in line, that is 1 for the most significant digits place. And the subsequent numbers will be formed by placing all the 16 symbols in the least significant digits place along with 1 as the most significant digit. Since the least significant digits place changes one after the another, therefore the place value of the least significant digit is going to be 16 raised to the power 0. On the other hand, if you notice, for all these 16 least significant digit symbol, we have got 16 ones. Therefore, the place value of the most significant digit in this case is going to be 16 raised to the power 1. Eventually, like this, when for the most significant digit we get to the symbol 9, once we use up all the symbols in the least significant digits place, after 9F, in order to form the next number, we are going to select the next symbol, that is A, for the 16 raised to the power 1's place, and the same drill will be repeated. Now after AF, what will be the next number? Well, in order to form that number and the subsequent ones, we are going to select the next symbol in line, that is B. And repeating the same drill, we will have a new set of numbers starting from B0 till BF. Like this, we will reach a point when for the most significant digit, we are going to select the symbol F. And repeating the same drill, we will have the next set of numbers starting from F0 till FF. Now notice, we have exhausted these two places with the last symbol that we had in hexadecimal. So what should we do now? We will reset these two places using zeros, and a new most significant place will be introduced having the place value 16 squared. And we are going to initialize this place using the symbol next in line, that is 1. Isn't it? So this is how the hexadecimal numbers are formed. Do remember, unlike decimal, here instead of 9, we have the last symbol as F. So 10 appears after F instead of 9 in case of hexadecimal. So that was all about the hexadecimal number system. Let's now have the comparative study of decimal, binary and hexadecimal number systems. Now coming to hexadecimal, we already have seen it has got 16 symbols. Now if you compare this with the decimal number system, in case of decimal, what are the symbols that we have? We have the symbols starting from 0 till 9. So value-wise, these are same. However, for A, B, C, D, E and F, we don't really have any symbols in decimal. But we know how the number systems progress. Therefore, if we compare the values, A in hexadecimal is going to be 10 in case of decimal. What will happen for B? It is 11 for decimal. C in decimal is going to be 12. Hexadecimal D is going to be 13. Now what about E and F? E is going to be 14 and F will be 15. Now tell me, hexadecimal's 10, that is the number after F. So what will be the value of 10 of hexadecimal in case of decimal? Well, it will be the next number after 15, that is 16, isn't it? So this is the comparative study of decimal and hexadecimal. Now in the previous session, if you remember, we did a comparative study on decimal and binary. And as a homework problem to you, I told you to find out all the numbers which can be formed in binary using these 4 place values. And I hope you did that. Now today we are going to fill this table up. Now before proceeding ahead, let me tell you about certain changes that we are going to make in this table. If you remember in the previous session, when we were talking about these blank spaces, I told you that these places can be filled up with zeros. And also if you recall, while determining the place values, we imagined these zeros. Let me remind you, I told you earlier that these 2 places can be filled up with zeros. So the pattern is 2 zeros, then 2 ones, then 2 zeros again, then 2 ones, then 2 zeros. So for this bit's place, the symbols are changing 2 at a time. Then again, for this place, we imagined that there are 4 zeros in here. So the pattern was 4 zeros, then 4 ones, and so on. And thus the place value 4. Finally, for this bit's place, we imagined there are 8 zeros in here, and there would be 8 ones. Therefore, just to concretize that idea, let's put zeros for real this time. Anyway, placing these zeros in the front, they won't make any difference. However, they will assist us to find out the decimal value's 4-bit binary forms for each one of them. Last time we found out the decimal 9 in binary is 1001. So what will be the value of 10? It is going to be 1010, right? You can always check that. Observe, the ones are placed underneath 8 and 2. So 8 plus 2 is going to be 10. And also, since we had exhausted this place, so it was reset, and a new symbol was introduced in the place next to it. Following this, what will be the value for 11 in binary? Well, it is 1011. Now what is 12? It is 1100. Since we had exhausted these 2 places, we had to reset them, and the new symbol 1 was introduced in this place. Coming to 13, it is going to be 1101. Basically, we are toggling the least significant bit. Coming to 14, it is going to be 1110. Since we had exhausted this place, so we reset that, and the new symbol was introduced in this place. Finally, 15 is going to be 1111. Notice, this is the last binary number possible using these 4 place values. Because for the number after this, since we have exhausted all these places with the symbol 1, we will have to reset all of them. And the new place, which is going to have the place value 16, will be introduced and initialized with the symbol 1, isn't it? Now interestingly, if you notice, in case of decimal, we have listed down 16 numbers starting from 0 to 15. And if you recall, all the 16 symbols of hexadecimal have the value from 0 to 15 in decimal. That is, from 0 to F, they have the value starting from 0 to 15 in decimal. So clearly, after 9, the hexadecimal A is same as 10 in decimal and same in case of binary 1010. So B is same as 1011, that is 11 in decimal. C has the value of 12, that is 1100 in binary. Then D in hexadecimal, which is also 13 in case of decimal. In binary it is 1101. E in binary is 1110, which happens to be 14 in decimal. And finally F, which is 15 in decimal, is 1111. So basically, these are all the different numbers in decimal and binary if we talk about all the symbols of hexadecimal. So that was all about the comparative study of decimal, binary and hexadecimal number systems. Let's now understand the representation of binary in hexadecimal. Now coming back to this table which we just have formed, if you notice, using only the single hexadecimal symbols or digits, we can represent 4 different bits in binary, right? Now, since binary bits are used in computation, we should also learn about the metric for data. So, if we talk about 0 or 1, which is called 1 bit, and 4 bits are called 1 nibble, then 8 bits or 2 nibbles are called 1 byte, then 124 bytes is known as 1 KB or kilobyte, 124 kilobyte is known as 1 megabyte or MB. Similarly, 124 megabyte is known as 1 gigabyte. 124 gigabyte is called 1 terabyte. Then 124 terabyte is known as 1 petabyte. And this metric goes on. Notice, 4 bits or 4 binary digits is known as 1 nibble. Here also, all the single-digit hexadecimals or the symbols of hexadecimal, they can represent 4 bits of binary. So, every single hexadecimal symbol can represent 1 nibble of binary, isn't it? This helps in representation of binary numbers in a shorter hexadecimal form. Let me illustrate that for you. Consider this binary sequence. Now, in order to convert this into hexadecimal, all we have to do is, from the least significant bit, if we go towards the most significant bit, grouping 4 bit at once. So, this is the 4-bit group, that is 4 nibbles that we have got. Now notice, if we consider 1010, which happens to be 10 in decimal, which is also represented by A in hexadecimal, so instead of this 1010, we can use A. Now coming to 1101, which happens to be D in case of hexadecimal, if you notice, we can represent this particular bit stream or nibble as D. Then again 0110 happens to be 6 in case of decimal, which is also 6 in hexadecimal. So for this, we can use the symbol 6 instead. Finally, for 0101, we can use the symbol 5, which is also 5 in decimal. So let's do that. So the 16-bit binary bit stream can now be represented as A, D, 6 and 5 using hexadecimal symbols. Notice the representation of binary. We were using the bit stream, and with the parenthesis, we were using the subscript. Similar to this representation, in case of hexadecimal, we will have A, D, 6 and 5. Along with that, using the parenthesis, we will use the subscript 16, which will denote the base of it. There is another way to represent these hexadecimal numbers, and that is keeping the digits as they are and appending a 0x as a prefix. Now, this kind of representation is helpful when we use to address the memory devices within the system. Because in case of memory devices, the address lines define the addresses, and they are quite long, to be really honest. So the representation using hexadecimal becomes easier for us to comprehend. So this was all about the representation of binary in hexadecimal. So in this session, we covered the topics hexadecimal number system. Then we had a comparative study of decimal, binary and hexadecimal number systems. Finally, we understood the usefulness of representation of binary in hexadecimal. Alright people, that will be all for this session. In the next couple of sessions, we are going to learn about the conversions from one number system to another. So I hope to see you in the next ones. Thank you all for watching.